Hi, and welcome to Trapezoidal Approximation. What we're talking about in this video is finding that area under the curve just as we would with a rectangle. However, we want to use trapezoids instead. You can see between those two diagrams that the top one, the triangles are kind of like poking out in all kinds of goofy directions. But if we use trapezoids underneath that, since trapezoids are all slanty like curves, then we can get a more accurate approximation of what's happening underneath our curve. So here's a summation example of the two types of approximation. The top one being a rectangular one. We would do the width of our rectangle, and then we would multiply it by all of those heights of our rectangles. So that's a midpoint one, so it's in between the two end spots. The one below is, the one below is the trapezoidal approximation. So it's very, very similar, but instead of doing like just particular points and finding the value of the function at those particular points, we're actually doing two separate points and then averaging those two values together to get the left and the right-hand side of our trapezoid. Now, we don't usually do that summation notation, so the way I would think about writing this thing is just the way you would do an area of a trapezoid. We get 1/2, because that's part of the formula for the area of a trapezoid. So we get this 1/2 right here. This b minus a over n, that's like how wide of a gap. So say we're going from like 4 to 7, we would have a gap of 3. And then we divide that into a certain number of trapezoids. So that 4 minus 7 would get us 3. We divide that into a certain number, let's say 3. And so 3 divided by 3 would get us 1. That would be the width, or in this case, the height of our trapezoids, because the bases is these two up and down pieces. And that's what we're going to plug into the function. Now you can see what those bases, the first and the last ones just have one of those bases used, and then the other ones have got a 2, and I don't know why that is. Let's take a look. I have this example where I've done a trapezoidal approximation. I've left a couple things out so we can kind of explore that idea of why is there a 1 and then a 2. So in order to figure out the area of this red trapezoid, the one that we start with, we need to do the two bases, which are odd because the bases go up and down. Our first base is going to be right at 0. Mel is really interested in this idea. First base right at 0. So we get 0 squared because we want to plug in to our function that we have, that x squared. And then we also want to do the next one over. We've done 4 intervals, and we're going to 2. So 4 cut into 4 pieces is going to be 1/2 to get one side of that trapezoid. So we've got a 0 squared, and we've got a 1 squared. We want to multiply that by 1/2 because that's part of our area of a trapezoid, this 1/2. And then this divide by 2, that is our height, because remember, the height of these ones is going to be 1/2 because we got 1/2, 1/2, 1/2. So we got a height for our 1/2 and we've got a height for our formula. So we plug that into the calculator. I'm going to not bore you with it, but it is 0.0625, which you can actually see in the lower left-hand side of the screen. When we do the next one, we want the next green piece, which is going to be like right over here. Well, okay, well, that's going to be just that same 1/2 again. Okay. Oh, we already used that. Remember that only the first one gets a 1, everybody else gets a 2. So that 1/2 gets used twice. When we go to the other side, it becomes a 1. So there's a height of 1. Well, we're going to plug in a value of 1 into our function. But that same value of 1 will get plugged into our squared function right here. So that'll also be a 1. We get the same sort of thing happening on the side over here. We get 3/2 getting squared, but then we also need a 3/2 for the purple side of this rectangle. So 3/2 getting squared. That was a very, very terrible 3/2. But then that last one, the other side of that trapezoid right here, it's not being reused. It's only being used one time. The first and the last one only have a value of 1 on them. You plug all those values into the calculator and you get this, which adds up to be 2.75, which is approximately the actual area, if you check it on your calculator, 2.667. So it's fairly close for an approximation. Let's try another one. This time I'm not going to bother with actually drawing the diagram. We just want to get the idea of what we need for that integration. So we always start with a 1/2, and then we need to do that a minus b to figure out, like, okay, well, how wide are we checking? Well, you can also just kind of use that with your head. We're going from 0 to 2, and the number of spaces that we're dividing that up by is 4. So we want to do 2 minus 0 over 2. So this is just part of our formula. The formula for a trapezoid starts with a 1/2, and this is our widths. That's going to be multiplied by, we need to evaluate the function at various places. The first one does not get a 1 because that one doesn't repeat. It's not reused. So our first value is going to be right at 0, plus we'll get 2 at our first thing that we're getting cut off at f of 1/2. Plus another one, 2 at f of our next interval spot is going to be at 1 because we want our widths to be 1/2 each time. I'm going to run out of space here. So plus 2 f of 3/2 plus, when we get to that very last one, since it's not being reused, the very last one will not get a 2. It'll just be f of 1 because that end one doesn't get touched twice. Those two trapezoids are not right on top of each other. So now we just got to evaluate all this stuff. So we get 1/2. And then that 2 minus 0. Oh, why am I dividing it by 2? This should be a 4. Sorry about that. So that's also going to be 1/2 for our width. And then we just need to evaluate all of these f ofs. So our function is right here, x cubed. So 0 cubed, well, that's 0, plus 2 times 1/2 cubed, that's 1/8. Plus 2 times 1 cubed, oh, that's just 1. Plus 2 times 3/2 cubed, that is 27/8. And then f of, not 1, but 2, f of 2 cubed is going to be 8. So this is going to be 1/4 of, let's see, 0 plus 2/8. So that is 1/4 plus 2 plus 27/4 plus 8. So that's 28/4 plus 8. So 28/4, that's 7. 28/4 is 7 plus 10, which is 17. Yeah, 17 times the 1/4 that we got in front. I don't know why I didn't write that first. So 1/4 times 17. So we get an approximate area of 17/4. If you check the exact area underneath it, it ends up being 4. And so we got 4.25, so that's pretty close. And you can find that exact area on your calculator. All right, we're going to try to do another trapezoidal approximation. This time it's a little bit grosser, so I actually drew a number line just to kind of help me out. Now, we want to divide this into 4 sections. So we'll have a divider right here. Oh, can I have a blue pen, please? I'll have a divider right here. I'll have another divider right here. And I'll have a third divider right there. Now, if I think about, I got to cut the square root of pi over 2 in half. You could do all kinds of crazy stuff with it, but you know what? Why don't I just make it the square root of pi over 2, and I just cut it in half by multiplying it by a half. Boom, done. I need the next one, which is just kind of like cutting that half in half again. So that would be like 1/4, and it still has that square root of pi over 2. Finally, we want one. Now you can kind of see we got each one at 1/4. So this will be at the square root of pi over 2 times 3/4. So we got 1/4, 2/4, which is a half, and then 3/4. Okay, so let's do that trapezoidal approximation. We always start with a 1/2 because that's just what trapezoids need. And then we need to do that b minus a, so that top minus bottom, over 2. So that's how wide this thing is divided by how many spaces we're going to do. We're going to divide by 4, not 2, because the number of spaces we want, or trapezoids that we want, is 4. So we've got the square root of pi over 2 divided by 4. I'm going to move this over a little bit because I need a lot of space after this. So come here. No, of course that's going to group. I should have known that was going to group. No, you listen to me. You listen to me when I'm clicking on you. Slide that over. There we be. Okay. Now we got to do a whole bunch of stuff. Hey. So we want to do the first one. That one is only going to show up one time. So that is just going to be the sign of 0. Done. Just sign of 0. Plus 2 for everybody else, because we're going to get things to show up twice. We'll get 1 for right here, and we'll get another 1 for right there. For those 2 trapezoids, it'll be bases for both of them. So why don't we just write it once and put a 2 in front of it? So that'll be the sign of that square root of pi over 4 squared. So that'll be pi over 2. I said that super wrong. You want to square this thing, all right? Square that thing. So that's pi over 2 times a 16th. Neat. Plus 2. And we want to evaluate the next one. So that'll be the sign of this piece right here. Well, that piece right there, we'll square it again. So we get pi over 2. And we square that 1/2, and that'll be a quarter. Plus 2, and we do the last one. I'm kind of in the way. Here, let me see if I can move myself over. There we go. So that'll be the sign of square root of pi over 2 squared. So that's pi over 2. I've done it 3 times now. Why can't I do it? And then 3/4 squared will be 9/16. I almost fit it in one row. Dang it. Plus the sign of square root of pi over 2 squared. So that's just going to be pi over 2. Note that since that's the last one, it doesn't get a 2 on it. Now, at this point, you might kind of say, oh, well, I don't even know what the sign of pi over 16 is. I don't know what the sign of pi over 8 is. I don't know what the sign of 9 pi over 32 is. I know what the sign of 0 and the sign of pi over 2 is, but I don't know anything else. So at this point, you just kind of jam it in your calculator, type all that junk. If you type that junk in properly, you get 0.5495, which is really, really close to the actual approximation, which is 0.5493 that you could find on your calculator. But I don't want to spend the video typing stuff into the calculator. So that's what you should be getting when you type it in. It's just a matter of typing it properly. And that does it for trapezoidal approximation. Reminder that there is that summation way of writing it, but we don't care about summations, so we're not going to worry about that. This is the way you should be thinking about it. When you start evaluating the function all those times, reminder that the first one and the last one have a 1, but every one of the other bases is a 2. But the bases are weird because the bases are going vertically, and your height is actually the width of your trapezoids. So thanks for watching. Bye-bye.